All right, buckle up, because today we're diving headfirst into Albert
Oh,
algebras.
yeah, Albert Algebras.
They might sound a little intimidating at first,
Yeah.
but trust me, this is really fascinating stuff. You ready to have your mind blown?
I think our listeners are going to love this deep dive.
I think so too. What's so captivating about Albert algebras is that they're like the superstars of this specific mathematical family, right?
Exactly, yeah. They're called Jordan systems.
Jordan systems.
But, these Albert Algebras, they're not just famous for fame's sake.
Right.
They're really the key to unlocking some profound mathematical truths.
So before we get lost in the excitement, let's define what we're dealing with here. What exactly is an Albert algebra? How would you explain it, say, to someone at a party, maybe who vaguely remembers high school algebra?
Okay, so imagine you have a box, but instead of holding just numbers, this box contains special objects.
Okay.
And these objects, they have 27 different parts.
Wow.
And we can add these objects, we can subtract them, we can even multiply them in their own unique way.
Interesting.
Kind of like how you learn with numbers in algebra, but
Yeah.
we're, adding a few extra dimensions in.
Okay.
And that, my friend, is essentially an Albert algebra, this 27-dimensional box of mathematical wonders.
A 27-dimensional box. That already sounds way more exciting than my high school algebra class. But earlier you mentioned that Albert algebras are like the superstars of Jordan systems. What makes them so special? It's got to be more than just their 27 dimensions, right?
Oh, absolutely. Imagine the smoothest, most perfectly symmetrical object you can think of. Something like a sphere, but even more perfect.
Okay.
In geometry, we have this thing called a cubic surface. And it's basically like a 3D shape defined by a very specific equation.
Okay.
And get this, no matter how complicated you make your cubic surface, you can always find exactly 27 straight lines on it.
Hold on, 27 lines, always. That already sounds mind-blowing. How does that even work?
It does seem counterintuitive.
It does.
Yeah. But it's true. And that's where our superstars, the Albert algebras, come in. Think of each of those 27 lines as having a secret code, like a unique identifier.
Okay.
And each of these codes can be perfectly represented by a piece of our 27-dimensional Albert algebra.
So it's like these Albert algebras are like a secret decoder ring for understanding those lines on the cubic surface.
Exactly. And it's more than just a simple code.
Okay.
The way these special objects multiply within the Albert algebra, it actually mirrors the geometric relationships between those lines on the surface. It's like they hold a map to a hidden geometric world.
Wow. This is incredible. It's like we're watching the secret language between algebra and geometry unfold in front of us.
Yeah.
And to think that this was all hiding within this thing called an Albert algebra, it's like we found this treasure chest full of mathematical gems.
And we're just getting started.
Oh, really?
This connection between Albert algebras and geometry, that's just the tip of the iceberg. Remember how we were talking about them being like the superstars of Jordan systems?
Yeah.
Well, they also have this amazing link to another VIP group in mathematics, and those are called exceptional algebraic groups.
Okay, whenever I hear exceptional in math, I know things are about to get interesting. What makes these groups so exceptional, and how do they fit into this whole picture with Albert algebras?
Imagine you have a perfectly symmetrical object, like a snowflake.
Okay.
And you can rotate it, you can flip it, you can reflect it. It still looks the same, right?
Okay.
That's the essence of symmetry.
Okay.
And these exceptional algebraic groups, particularly the ones labeled G2, F4, and E6, these are like the ultimate rule books for these kinds of symmetries. They're dictating how things behave under these transformations in some pretty high-level mathematics, even physics.
So these exceptional groups are like the guardians of symmetry, making sure that everything stays balanced and beautiful, even in these like really abstract mathematical worlds.
Exactly. Yeah. And here's the mind-blowing part. These Albert algebras, they act like secret keys that unlock these exceptional groups. It's like having a master key that opens up this vault of knowledge about symmetry and structure in the universe.
So we've got geometry, symmetry, even a touch of physics, all woven into this incredible tapestry of Albert algebras. What other surprises are hidden within these 27 dimensions?
Well, get ready to be surprised again, because there's been this recent discovery in the world of Albert algebras, and it's got mathematicians really excited. It involves something called an isomorphism class of Albert algebra over integers.
Isomorphism class, integers. It sounds a bit like we're back in math class. Can you break that down for us?
Of course.
Okay.
Imagine you have a set of building blocks.
Okay.
You can arrange them in different ways to create different structures, but, no matter how you rearrange them, they're fundamentally made of the same stuff, right? That's kind of what an isomorphism class is. It's like this family of mathematical objects that are essentially the same, but maybe they look different on the surface.
Okay, so we're talking about different versions of Albert algebras that share like this common core. But you said these are over integers. What's so special about that?
Integers, those whole numbers we all know and love, 1, 2, 3, and so on, they've always had this really special place in mathematics. They're like the atoms of the mathematical universe.
Right.
And for the longest time, mathematicians thought they knew all the possible ways to build Albert algebras using these integers. But guess what?
What?
They recently stumbled upon a brand new type. It's like discovering a new element on the periodic table.
Wow, that's a huge deal. So how did they even find this new Albert algebra?
It was a combination of, some brilliant mathematical intuition and some really, really powerful computing. Two mathematicians, Noah Melkes and Benedict Gross, they were doing these incredibly complex calculations.
Okay.
And they started to notice these strange patterns.
Okay.
And they realized that these patterns, they hinted at the existence of this new type of Albert algebra.
So it was like they were exploring this dark forest and they saw this like faint glimmer of light through the trees and it led them to this hidden treasure.
Exactly. And once they knew what they were looking for, they were able to use this clever technique called isotopes to finally bring this new Albert algebra to light.
Isotopes. Now that sounds strangely familiar. Don't they have something to do with chemistry?
You're right. In chemistry, isotopes are these atoms of the same element. They have same number of protons, but different numbers of neutrons.
Okay.
In math, we've kind of borrowed that term to describe a way to tweak these Albert algebras to slightly change their structure, but while still keeping their core properties the same.
Hmm.
Think of it like taking a basic cookie recipe
Okay.
and adding different ingredients to create, endless variations. Chocolate chips, nuts, you name it.
I love that analogy.
Yeah.
So by using these isotopes, mathematicians can create all these different flavors of Albert algebras and explore all their unique properties.
You got it. And in this case, these isotopes, they were the key to unlocking this brand new isomorphism class over those integers, really proving that there's still so much more to discover about these fascinating mathematical objects.
This is blowing my mind.
Yeah.
It's like we've been exploring this well-mapped territory of Albert algebras, and suddenly, bam, we discovered this hidden passage to a whole new world within the integers.
Exactly.
Makes you wonder what else might be out there.
Yeah, that's the million-dollar question, isn't it?
Yeah.
Now that we know there's at least one new type of Albert algebra hiding within the integers, it's like mathematicians have gone on high alert.
Yeah.
Looking for more.
So it's like that feeling you get when you find like a dusty old treasure map in the attic.
Okay.
Suddenly the chase is on.
Yeah.
So what are mathematicians doing to try and uncover these like elusive Albert algebras? What's the strategy?
Well, they're pulling out all the stops. They're combining these, cutting edge theoretical tools with brute force computational power. It's a two-pronged attack on the unknown.
Okay, I'm intrigued. Tell me more about this two-pronged approach.
Okay.
Where did they even begin?
So on the theoretical side,
Okay.
imagine that mathematicians are developing a whole new set of spectacles,
Okay.
lenses that allow them to see these Albert algebras with even greater clarity and precision.
Wow.
They're looking for, any subtle patterns or any hidden relationships that maybe have been overlooked before.
Wow.
They're really trying to understand this intricate dance of these mathematical objects at a much, much deeper level.
So it's all about like sharpening their intuition, developing almost a sixth sense for sniffing out these hidden mathematical treasures.
Exactly.
Yeah.
And that's where that computational power comes in.
Okay.
Imagine these massive supercomputers working tirelessly, crunching through these mountains of equations and data. They're like digital explorers, charting this vast and uncharted territory of the mathematical world.
It's amazing.
Searching for those unique fingerprints that these hidden Albert algebras might possess.
So it's like panning for gold,
Yeah.
sifting through tons of sand and gravel to find those like rare, precious nuggets.
Exactly.
And in this case, each nugget is a brand new type of Albert algebra, holding the potential to unlock even more secrets of the mathematical universe.
That's right.
What an incredible journey this has been.
It has.
We started with these like seemingly abstract objects, these Albert algebras.
Yeah.
We uncovered their hidden connections to the geometry of 27 lines on a cubic surface.
Yeah.
their role as secret keys to understanding symmetry.
Amazing.
And now this mind-blowing discovery of a whole new type hiding within this, like, familiar world of integers.
Right.
It's incredible.
It really speaks to the power of curiosity and that relentless pursuit of knowledge.
Yeah.
And the best part is, this is just the beginning.
Exactly. Who knows what other mathematical marvels are out there? Just kind of waiting for a curious mind to stumble upon them.
Absolutely.
Well, that's a wrap on another exciting deep dive.
It was a good one.
Until next time, stay curious, keep learning,
Absolutely.
and we'll catch you on the flip side.
See you.